DeepMind's AlphaCode solves programming challenges, OpenAI's language models solve math problems, and Eleuther AI releases a 20 billion parameter language model open source. Welcome to ML News. Before the rest of the video, this video is sponsored by Weights and Biases. Weights and Biases builds developer tools for machine learning, for researchers, for practitioners, for juniors, for seniors, whatever your favorite flavor of yogurt is. They don't care, they build products for you. Except cherry. Who likes cherry? Today, I want to talk to you about a feature called artifacts. So artifacts essentially are files in the cloud, but you're probably going to use them mostly for two things: data and models. Both of these things are notoriously tricky to work with. Dataset is too large to check into Git. We need to keep it up to date. We may have different versions of it, and models even more. We want to save the outputs of our runs into models that we can then use later, maybe introspect. And these things are also versioned, and we want to depend on them. So when I did this, I had to save the model to some special folder, and then I had to go grab it from that folder, put it on all the machines in a correct folder, and then reference that folder from all my scripts that would then consume this model. With artifacts, this gets a lot easier. So we first uploaded the original data set to an artifact. Now we're going to consume that artifact, split the data into train, validation, and test data, and then emit those things as artifacts. So if there's a new version of the raw data available, I can simply run the same script depending on the same thing, and it will create new versions of the train, validation, and test data. You can make this arbitrarily complex, but I hope you can see the point here. The same goes for models. If your run outputs and saves some kind of a model, you can log that as an artifact, and from then on you can consume that model in all subsequent runs. So here's one of my models. It's a CNN. You can see it's already version 116 of that model, but you can see all I have to do to use this model in any code, in any script in the future, I simply call the download method on the artifact, and it will be available locally. And as I told you, you can do this with any file, but since this is a model of a deep learning framework, Weights and Biases understands it and gives me a neat viewer where I can actually introspect the model and look at the shapes and even at the weights of my CNN. So I think this is incredibly powerful. These things quickly get complicated with versions and scripts building upon other scripts, and the artifact framework really helps you to make sense of all of it. There's even the possibility that the data stays in specific private buckets with access controls, so not everyone in your team has access to all of the data. Of course, artifacts are only one of the features of Weights and Biases. If you're interested, please check them out. Free accounts are free, academic accounts are free, enterprise accounts cost a bit, and that's it for this week's sponsor spot. Thanks a lot to Weights and Biases. Let's get into the video. Hello and welcome to ML News. How's everyone doing? We'll jump into our first story, which is that DeepMind has released AlphaCode, which is a model that can take a programming challenge description. You might know these descriptions if you've ever done competitive programming or had a programming exam or something like this. So we have one right here, given two strings S and T, both consisting of lowercase English letters. This is kind of overly formal, but it kind of details a procedure. So you can press the backspace button, and as you type the string S, and then the character is deleted. And the question is, can you get from the string S to the string T by pressing the backspace button at the appropriate times? So for example, here is the input. You have four inputs. The first string is A, B, A, B, A. That's S. And BA is T. The question is, can you type S? And you always have the choice of typing the button of the letter or the backspace button, and you have to end up at T. So we'll try this. For example, first type a backspace, right? Then there's nothing. Then we'll type B, A, and then we'll type B, and then a backspace. And all of that should result in BA. So we are going to have to write a program that figures out if it is possible to get to T from S. And they have a bunch of these example inputs right here. They have some notes. And as you can see, this is a text description. This is the problem. You feed this to a neural network. The neural network will output a program, an actual piece of code, in this case, Python code that actually reads the input from the provided file. Not only these, by the way, so there's going to be other test cases, not just the ones that they have as an example right here, implements the algorithm all by itself. There's no human in the loop right here, and then prints out the correct answer according to the specification in the textual description of the problem. This is, let's say, quite challenging. This is a hard problem, especially given the description is in natural language, and AlphaCode solves this. So they have submitted AlphaCode to programming challenge competitions, and it scored at about a 50th percentile of humans. Now, that is not super duper good, as lots of these programming challenge competitors are maybe students, people who get into programming, who kind of want to prepare for an interview or hone their skills a little bit. So it is at an intermediate level right now, but it is definitely more than I would have expected. So the way the model works is that, kind of like Codex, it is pre-trained on GitHub problems, but then it is fine-tuned to solve exactly these code challenge datasets. So there exist datasets given problems in natural language description and solutions, and the solutions are programs, obviously. So DeepMind takes their pre-trained model and then fine-tunes it on these pairs of problem description and solution. Now, when it comes to actually solving a problem at inference time, they take that problem description, they feed it to the network, but they don't just output whatever the most likely output of the model is. They actually sample a giant amount of possible samples, which means possible programs that the model suggest. Now, a lot of them are going to be wrong. So what they do is they filter those programs based on the small subset of provided solutions that you get in the problem descriptions. In this case, here they have 4 different example inputs, 4 different example outputs that will filter out. In the paper, they say that will filter out over 99% of possible solutions very often. Now, filtering alone isn't enough, as that still leaves them with a large number of potential solutions, and very often these coding competitions, they're limited to a very small number of submissions. In this case, I believe it was 10 submissions. So in order to achieve that, they have a step on top of that where they cluster solutions. So they try to cluster together programs that are textually different, but essentially don't do a different thing. Like maybe the variable names are different, maybe the same algorithm is implemented in a slightly different way. So they have a clustering algorithm that lumps those together, and that brings them down to the 10 submissions that they're going to make. These are not the only parts of the system by any means. There is a large number of components to this system that really brings up the system to the level of the average human where it currently stands. Now, there's a website where you can explore the solutions given by the model, and you can look at sort of the attention heads of the different models, like what they pay attention to along the different types and things they do. So on the left here, you see the description of the exact problem we saw before. This is pure text with natural language. And on the right, you see the solution. So as you hover over this right here, it shows you token probabilities, and it shows you according to what this token is decided upon. So for example, when I hover over the line S is the input right here, you can see that on the left, it focuses on this text right here. On the first line of each test contains the string S. When I focus on T, it focuses mostly on the line below where it describes whatever T is. The attention is not only to the problem description, but also within the program that was already generated, and it's generally pretty cool to explore. I recommend you give it a try. As I said, there is a detailed paper with this where they describe exactly what the components of the system are and so on. Give it a read. It is quite a lengthy paper. I believe it has its own table of contents. Yes, it does. About 30 pages, so not too long. So my question is a little bit, when I think back at like AlphaGo, AlphaZero, and so on, those models also didn't start out world class, but they were able to quickly get there and beyond simply by doing more self-play. In this case, it seems the dataset is a limiting factor. So there's only a finite amount of these human-generated programming competition data points. The question would be, is there a way that we could come up with synthetic data, like synthetically produced code samples? And is there a way that we could make them progressively harder and harder and harder in a self-play kind of style? Because if that's the case, and if we really get this data generation part right, it could also be that the coding AI here will become, you know, like good beyond limits. but I am kind of skeptical about that. We also have some different voices giving their opinions on this. One of these, for example, is Dmitry Bogdanov, who is a competitive programmer, has done this for a while apparently, and puts it a little bit into perspective, saying it is impressive, yes, but he says human level is still light years away. Mentions again that 50th percentile in these competitions doesn't necessarily mean that it's particularly good, that a human challenge is often not only the difficulties of the problems, but also the limited time you have available for them, and the disparity between humans and the machine of the approach, namely that 99% of all programs that AlphaCode outputs are wrong, whereas a human will maybe make a mistake in the first try of the implementation, but doesn't need to generate thousands and thousands of hypotheses until they get a correct one. And certainly they don't evaluate all of these hypotheses by filtering them using the tiny amount of examples they have. So humans and machines, they seem to have a sort of fundamentally different approach for now to solving these problems. Yet I can definitely see a version of AlphaCode that more iteratively takes into account sort of partial programs and does a more guided search for the rest. And ultimately, yeah, humans also, they run their program on the small test examples, and if that doesn't work out, they're like, wait, something's wrong. So this is an exciting field. I'm very curious where it goes. Next news, OpenAI releases a blog post called Solving Some Formal Math Olympiad Problems. They detail how a language model that was fine-tuned is able to solve formal mathematics problems. This is very, very cool. So other than in AlphaCode, these problems actually come with a formal description. They are defined in a formal language that is amenable to be proven, yet still to apply language modeling to this problem and then do some post-processing obviously is quite a hard task. So the reason they use language modeling right here is that other than in chess or anything like this, the action space is huge. It's actually infinite in proving formal mathematics because you can just invent new things by yourself. They do have a set of tactics that the model is kind of allowed to apply, but still the action space is infinite, and the language model helps them to determine what are the most likely next steps that they want to do if they want to solve this proof. The other thing that differentiates them from games is what they call the lack of self-play opportunity. There's no reward to people playing against each other or anything like this, which usually serves as sort of a curriculum method. As the agents play against each other, they sort of level each other up in skill. Now, to combat that, they have quite a smart data generation and sampling process where they start off with some hand-provided samples of various difficulties of where they want to go, and then they start with the lowest ones that they might be able to prove with the current technique of language model plus proof search. Note that it is not only a language model, it's combined actually with a proof searcher that is guided by a language model. And as they prove more things in the, let's say, easier statements, they add those to the data set, which they then reuse to train the language model. So in this case, the model automates its own curriculum by proving more and more statements. Now, this isn't obviously without challenge because math is full of trivial and nonsensical statements that you can prove to be true, so choosing even what to prove becomes a hard task. But nevertheless, using this approach, they're able to generate quite good proofs. In fact, they're able to outperform pure proof search by quite a bit. And they're also able to solve problems of the International Math Olympiad, which is usually quite a hard problem. There is a paper to go along with this. Give it a read if you are interested. EleutherAI announces GPT-Neo X20B, that is a 20 billion parameter model, and by the time you're watching this, the model is going to be available for free. It's going to be kind of a pain to run it because it's so big, but you can just download it. I've made an entire video interviewing Connor Leahy, who is one of the co-founders of EleutherAI and has worked on this project, about how this came to be, about how they, got their hands on the hardware necessary and so on. So if you're interested, check that out. Another new paper about StyleGAN XL. The paper is called Scaling StyleGAN to Large Diverse Datasets. That is a hard thing to say. Scaling StyleGAN. Like, try saying that over and over again. scaling StyleGAN. So the TLDR here is, with the right training strategy, StyleGAN achieves state-of-the-art on ImageNet. So if you remember, StyleGAN always used to be trained on very specific data sets. StyleGAN is the thing that powers thispersondoesnotexist.com, this shoe does not exist.com, this sneaker does not exist.com, and so on. But these are all very limited data sets, often of the same thing, and approaches like BigGAN have traditionally been better at modeling diverse data sets such as ImageNet, which has many different things. The authors here show that with the right training protocol, namely projected GANs, upsampling, and so on, progressive training, you can get these GANs to the level of ImageNet. This is also built on StyleGAN v3, which means that it kind of retains, it has these translation invariance properties. I have reported on this on ML News previously, so go check that out if you are interested. So they're able to generate images up until 1024 to 1024 resolution, which is quite impressive. They can also invert images. So on the left, you actually see a real image, and on the right is an inverted image where they have fed this into the GAN and then figured out the latent codes, and then they're able to edit the image on the right as they see fit. And as I said, it retains the translation equivariance from StyleGAN 3. If you're interested, check out their website and check out their paper. R55. It's AR5IV. That is a website. It's ar5iv.org. What it allows you to do, it allows you to view archive articles as HTML5 web pages. I'm not exactly sure how it's pronounced. I was told it's pronounced R5, but then again, it should probably be R55, like the way it's written. I don't know. Also, the browser showed me a warning when I went on this website, asking me whether or not I have maybe confused it with archive. So yeah, this might be just a giant phishing attack. But it is pretty cool. Here is an example that they give. Now, my browser is dark mode, so I don't know if that's available in light mode, but you can see that the references are real, true links that you can open as a pop-up. There are still some kind of artifacts right here, as you can see. Equations are rendered nicely, and also the side note, the footnotes here are rendered right beside the text. I don't know what happens if I zoom in. Okay, they just are pop over. Also, it allows you to jump to equations and then using the back button, jump back to where you were. This is the greatest thing ever. The amount of times I had not clicked on like an internal reference on a PDF just because I was like, no, I'm not gonna scroll back to where I was. So thank you, check out R5. Okay, we have some helpful things this week. The first helpful thing is Yitai saying they've released over 170 pre-trained transformer checkpoints of many different shapes and sizes as part of their paper. This is by Google Research. Check out the Scaling Transformers paper, the Scaling Transformers repo, and the models released. Thank you. FFCV is a library by the lab of Alexander Madry that makes training machine learning models fast. If there's ever like a buzzwordy title that says nothing, it's train machine learning models fast. So they provide a set of sort of throw-in replacements, for example, for data loaders that will just kind of speed up common use cases of training neural networks. They claim their code is hyper-optimized, removes bottlenecks, it's super-duper pipeline and parallel and all of that. So if speed is an issue for you, maybe give this a try. OTT, or Optimal Transport Tools, is a toolbox for all things Wasserstein, as they call it. It is an optimal transport library for JAX. Sumit Chintala advertises Diet GPU, which is a lossless compression algorithm for NVIDIA GPUs. The code of this is available. It's authored by Jeff Johnson, and what it does is it can compress stuff and uncompress stuff on GPUs. So if you have a slow network and you have a distributed training and you really care about making this fast and efficient, what you can do is you can compress stuff that you need to send over the network on the GPUs, send it over, then uncompress it. This library will make the compression and uncompression part really fast and really efficient. All right, that was it for helpful things. I hope you got help. The User Bremen79 on Reddit says the ICML 2022 conference is changing their review process slightly. So now there are two phases. In phase 1, the reviewers just give a recommendation. If there are 2 recommendations that are negative for a paper in phase 1, it is already rejected. I guess this is a goal to cull down on the amount of papers that have to be seriously reviewed. It's all the more important now that your paper makes a good first impression. So they say the meta reviewer can reverse this outcome. Okay. Another change is that reviewers do not make accept or reject recommendations in phase 2. The meta reviewers will decide based on the reviews. So I just write my review and then the meta reviewer reads it and integrates it all, instead of me saying, well, this is a 7 or this is a 4 or this is a strong accept or a weak accept. Now, technically it shouldn't make a difference, right? Because like my score that I would usually put is just kind of a conglomeration of what I said before. But, tiny changes like this, because we're humans and we're not consistent and we're not, we're not attentive enough, tiny changes like this might actually make a difference. I'd be interested to see some statistical analysis after the fact of what this did. If you're interested, the entire process is detailed in the ICML 2022 review form. Now, it just occurred to me that the submission deadline was actually last week, which I should know. So if your paper is not pretty and doesn't make a good first impression, then you just gotta hope for that really good meta reviewer that recognizes its inner beauty. This is a little bit older, but I hadn't seen it at the time. There is a blog post on Meta AI's research blog saying harmful content can evolve quickly. Our new AI system adapts to tackle it. So they describe a system that they call few-shot learner, which essentially means that it's a system that can monitor harmful content and adapt quickly to new harmful content because it's ever evolving. I find a few things interesting right here. First, on a sort of a scientific level, what is pretty interesting is that the model doesn't only consider training data, so data that has been labeled as harmful or not harmful or borderline or anything like this. It does do that, but it also takes a description of the policy, like a textual description of the current policy. And by doing that, it's able to adapt to policies over time, having seen, with this policy, this stuff is okay, and then with this new policy, this other stuff is okay. So the fine-tuning process can potentially happen with less data. I found this pretty interesting to actually provide the policy itself to the model. The other interesting thing is just this video right here. So as you can see, the people here, they're interacting with the internet and they see harmful content and they're like, oh no, I'm gonna log off. Oh no, all this harmful content. And then, there's the system. They describe their system. Oh yeah, whoa, okay. So now they filter all of this new harmful content. And then at the end, look what happens. Wow. Everyone's smiling, look, they're smiling, this is just, it is so wholesome. Thank you, Meta, thank you. The few-shot learner. Thank God all the harmful content was prevented from destroying smiles. Now, okay, on a more serious note, it is a hard problem, right? There's no way you can monitor all the content all the time. There's no way you can train a static system because sort of the meta of bad content, of bad language, of people bullying each other and so on is always evolving. So props to, Meta for actually trying to tackle this problem because, what's the alternative? Shut down all communication. That's not going to happen. Tell people to be nice. Well, try. But I see a bit too much complaining about this, and yeah, I do like that they're actually tackling this problem, and I find the approach to be cool. It's just the marketing that's a bit cringy. But what am I saying? I'm wearing sunglasses indoors. Okay, last news for the day. MIT Technology Review says, this company says it's developing a system that can recognize your face from just your DNA. Now, people have been extremely skeptical of statements like these. This is a company that deals in broad language with law enforcement, searching people, security, surveillance, and so on. And, you might debate the merits or unmerits of that in a separate topic. But the particular question of can we actually get someone's facial features from their DNA is highly debated. Just to be said, the company isn't only focused on that, it's called CoreSight, and they have different plans. These are not systems that run right now, these are sort of future plans to do things. One of them is this DNA to face thing. Now, I do feel the criticisms of this are often maybe overly skeptical, let's say. Now, again, I don't mind the skepticism about the applications of this, but the possibility, like there's a reason that children often look like their parents. Your facial structure is in large part determined by your genetic material. Now, the article points out that obviously age and environmental influences also have big impacts on that. So no doubt about that. And they make a good point in that they say the technology will probably not be able to tell you the exact number of millimeters between the eyes or the ratios between the eyes, nose, and mouth. And those are some of the features that the current facial recognition technologies rely upon. So since we can't get those features accurately from genetic data because they're maybe more environmentally determined, the current facial recognition algorithms wouldn't work. However, I don't see the extrapolation discussed right here, in that I would think it might be absolutely possible to train facial recognition algorithms that only use the features that we can read from the DNA. Like the argument that the face reconstructions that the DNA data gives us doesn't work with current facial recognition software is almost a moot point by then. Question is obviously how accurate it's going to be, and again, whether or not you even want to do this in the first place. But let me know what you think. Should this be done? Can this be done? And would you want to do it? Let me know in the comments. This was ML News. Thank you so much for being here. I'll see you next time. Bye-bye.